Hi there, folks. Today we're looking at solving absolute value equations. But before we get into solving absolute value equations, let's remind ourselves of what the absolute value is. The absolute value is the distance from zero, okay? And the symbol for absolute value is these two little bars that we put around the number, okay? They fall into the same category as inclusion symbols when we're talking about order of operations. So keep that in mind as well. They're grouping symbols. They go around things just like parentheses, but these guys actually do something, all right? They cause us to count the distance of that value from zero, all right? And if you've ever measured things in terms of distance, like using a ruler or a tape measure, you might notice that there's only positive numbers on a ruler or tape measure. We don't measure things in terms of negative, all right? So when we count to something, even if it is a negative value, we count how many units away from zero it is in terms of the positive, all right? For example, so I've got my number line here. Right here, it says the absolute value of -5. So think about where -5 is right here. Count how far away from zero it is. So here's zero. Ready? Let's count. 1, 2, 3, 4, 5 units away. Okay? And even though we're counting in the negative direction, the distance is 5 units. So the absolute value of -5 would be +5. Okay? If I look at the next guy, it says, hey, the absolute value of 7. So if I count from 0, so 0 is right here, right in the middle. If I count to 7, that's 1, 2, 3, 4, 5, 6, 7 units away. All right. So the absolute value of +7 is also 7. And so one of the things that students start to do is they say, oh, the absolute value always makes things positive. Well, if it's already positive, it stays positive, okay? So when we're measuring things, we always count in terms of positive. So here, the absolute value of 4 would be a 4, okay? It's 4 units away from 0. The absolute value of -6 is a +6 because it's 6 units away from 0, okay? So now we're going to apply that to solving equations. And if we consider the following, so these are really simple absolute value equations. But if I had the absolute value of something equals 5, think about what value would give me a 5 when I plugged it into the absolute value. And there should be one that's really obvious because it's written right above this thing. Notice absolute value -5 equals 5. So right here, that's telling me that x could be a -5. Right? Because the absolute value of -5 is a 5. But now look back to your number line, okay? The absolute value of -5 was a 5 because that was 5 units away. What other thing is 5 units away? And hopefully you're looking at this and say, well, 5 is 5 units away. That means x could also equal a 5. And wouldn't each of those be true? Like if I substituted in, if I plugged that -5 in for x, the absolute value of -5 is a 5. But if I plug the 5 in, the absolute value of 5 is also a 5. All right? So we're thinking about what things are 5 units away. Same thing with the next one. It says the absolute value of x equals 8. Well, what things would be 8 units away from 0? Well, x could be a -8. That's 8 units away. Or x could be a +8. That's also 8 units away. All right, so each of those has an absolute value of 8 because they're both 8 units away. And so the theme here is that the absolute value, when I solve absolute value equations, I end up with two answers most of the time. All right, because there are two different things that are that far away from 0. Okay, so when we're talking about the absolute value, if the absolute value equals a 2, well, there's two values that are 2 units away from 0. Okay, a +2 and a -2. The absolute value of something equals 5, well, it could be a -5 or a +5. Those are both 5 units away from 0. Okay, and then we look at this guy, it's a little special case here. The absolute value of something equals a -3. Well, when will the absolute value equal a negative? Where is -3 on your tape measure? And the answer is it's not on there, okay? The absolute value will always equal a positive. So if we see the absolute value equals a negative, that's impossible. That's when we say no solution. Okay, so again, the idea here is the absolute value typically gives us two answers unless we're talking about something like that last one, which is impossible. So watch out for that special case. Okay, and so kind of here's how we approach this then. So basically the same thing we were just doing, like when I had the absolute value of x equals 5, it could be a 5 or a -5. Those are both 5 units away from 0. Okay, so the absolute value is just like solving two linear equations. If I have the absolute value of A equals B, well, then A is either the positive version of B or A is the negative version of B. It's either of those two things that's that same distance from 0. okay? And here's what that looks like when I do it in terms of a more complicated equation. See, like here, I have the absolute value of x plus 4 equals 10. So ignore that x plus 4 thing. Just say absolute value equals 10. Which two values are 10 units from 0? Well, one of the values that's 10 units from 0 is negative 10. The other value that's 10 units from 0 is positive 10, which means x plus 4 equals negative 10, or x plus 4 equals positive 10. I approach it the same way that I did these guys up here, but instead of just having an x inside there, I have an x plus 4. And all we're saying here is that, hey, that absolute value equals a 10, which means the thing in the absolute value is either a 10 or a negative 10. It's one of those things. And now I solve each. So I always do the positive version and the negative version, and now I solve these two equations. If I solve the first one, subtract the 4 from each side. I was a little off there. Oh boy, I'm having some trouble. So I get x equals a negative 14. And then here, I subtract the 4 from each side. So I get x equals a positive 6. And that's it. Those are my two answers. And watch what happens if you plug it in. If you plug the negative 14 in, you get negative 14 plus 4. That gives me the negative 10. That's one of the values that's 10 units away from 0. So the absolute value negative 10 is a positive 10. If you plug the 6 in, you get 6 plus 4 is a 10, a positive 10. Well, that's one of the values that was 10 units away from 0. So the absolute value of positive 10 equals a 10. So you can kind of see how that works when you plug them back in. That first value gives me the negative 10, which is 10 units away. The second value gives me the positive 10, which is also 10 units away. And that's it. I just get these two answers. All right. And this is a little different from any other linear equation we've ever solved. Usually we only have one answer. Now we're getting into these situations where we can have more than one answer. Okay. If I look at the next one, same kind of thing. If I look at this, if the absolute value equals a 6, that means I got to think about the two things that have an absolute value of 6. The two things that are 6 units from 0. Well, that would be a negative 6 and a positive 6. So the 2c minus 2 equals a negative 6, or the 2c minus 2 equals a positive 6. And now I'm just going to solve each of these things, okay? Let me scoot that up. I didn't give myself a whole lot of space here. But now I solve each of these the same way I've always solved. So here, to undo subtracting 2, I'm going to add the 2 to each side. And now to undo multiplying by the 2, I'm going to divide by the 2. Same thing with the second equation. To undo subtracting the 2, I'm going to add the 2. Whoop. Clearly, I should be writing in blue when I get to that point, right? I don't want to make anybody feel uncomfortable. So let's, whew. And how to undo multiplying by the 2, I divide by the 2. But again, if you plug these back in, we plug values back in to check to make sure we've done it right. If you plug the negative 2 in, we get a negative 6 in the parentheses, or in the absolute value. Well, that's one of the things that was 6 units away. And the absolute value negative 6 is a positive 6. If you plug the 4 in, you get a positive 6 in the absolute value. That's the other thing that's 6 units away. And the absolute value, that gives me a positive 6. Okay, that's why we end up with two answers, because there's two things that are 6 units away from 0. Okay? If I look at the next guy, it says the absolute value of t plus 2 equals a negative 5.5. Well, think about which two things are negative 5.5 units away from 0. And hopefully you're going, well, I can't measure that far from 0. When I measure, I always measure things in terms of positive. So can the absolute value equal a negative 5.5? And the answer is no. Whoa, this thing just jumped on me. The answer is no, so this one is no solution. Okay? So just watch out for that special case. The absolute value can't equal a negative. The absolute value is measuring how far from 0 we are. Well, we can't be negative 5.5 units away. We measure things as positives. Okay? If I look at the next one's a little bit tricky, because you might be looking at it going, there's a bunch of extra stuff, not just the absolute value. Well, think about it in terms of order of operations. Absolute value symbols are inclusion symbols. So we have to undo those last, all right? Which means I have to undo the subtraction. I have to undo the multiplication before I can undo those absolute value. So here I'm going to get rid of the subtracting 4 by adding 4. And you can always also think of it as getting the absolute value by itself first, okay? But again, if I'm working backwards sort of operations, I have to undo the absolute value last. Inclusion symbols go last. So now I have to undo that multiplication. To undo multiplying by 2, I divide by 2. Now I can start talking about getting rid of that absolute value. And so to get rid of the absolute value, I think about what it says. Absolute value equals 3. So let's see, there are two things that are 3 units away from 0. There's a negative 3 is 3 units away from 0. And a positive 3 is 3 units away from 0. So that means that this thing could equal a negative 3 or a positive 3. And now I solve each. Here I subtract the 5. And I get x equals a negative 8. Here I subtract the 5. And I get x equals a negative 2. And once again, if you plug each of those back in, the negative 8, if you plug it into this step right here, is the easiest place to see it. The negative 8 gives us the negative 3 in the absolute value, which is 3 units away. So the absolute value, that equals 3. The negative 2, when you plug it in there, gives me the positive 3, which is 3 units away from 0. So that gives me the positive 3 when I do the absolute value. Okay? But again, the easy way to just think about this is you're just doing the two versions of that thing. Okay? Every absolute value has two different versions in terms of that distance. Okay? So that means whatever I have over there, whether it's a 3 in this example or a 6 in another example, I say this thing equals the negative version and this thing equals the positive version, and then I solve each. Okay? The only other thing I have to do is watch out for that special case. Absolute value can equal negative. That's when it's no solution. Okay?